Hello, ladies and gentlemen. Today is Pre-Calc Lesson 16. We're doing complex fractions, abstract equations, division of polynomials. Today will be a little different. I've actually already written the lesson out, had some technological issues. So if you need to pause at any point, please do. Okay, that might be more so than usual. Now, let's talk about complex fractions. Okay. Complex fractions are fractions that contain more than one fraction bar. And when we are solving them, what we will do is multiply by 1 creatively. And remember that the product of a number and its reciprocal is 1. So similarly to what we do if we have a fraction in our denominator, we will be reducing these fractions. So here's our whole first example. Okay. We have x over a plus m over b plus c over d. Now, if we look at our bottom here, okay, we want to combine these two into one fraction, which gives me bd plus c over d. Okay. And in this box here, I want to simplify this so that I don't have a fraction in my denominator. So I multiply by the reciprocal of my denominator, which is d over bd plus c. If I do that here, I have x over a plus md over bd plus c. Again, in my denominator, I want to combine that into one fraction. If I do that here, I get a times bd plus c plus md over bd plus c. And again, I multiply by the reciprocal of my denominator. Doing that gives me my final answer, x times bd plus c over md plus a times bd plus c. Okay. Now, you don't have to distribute out your terms, but if you did, your answer would look like this. Either one is completely acceptable. Okay. Let's do another example. Okay. We start with a over x squared plus b over x over m over x squared plus k over xc. I want to combine my terms in the denominator and the numerator into one fraction. Looks like this. A plus b over x squared and mc plus kx over x squared c. And I multiply by the reciprocal of my denominator. Gets rid of my denominator, and I notice that my x squareds can cancel on the top and bottom, leaving me with my final answer, c times a plus bx over mc plus kx. If you want to distribute your c, you can. Does not matter. Okay. Our next topic, we have abstract equations. In our abstract equations, you need to find the least common denominator over and over and over. Okay. So let's just do an example. We're going to solve y equals v times a over x plus b over mc. We're going to solve that for c. So the first thing I'm going to do is I'm going to divide both sides by v. Now, after I divide by v, I'm left with a over x plus b over mc. I'm going to bring the a over x over to this side to isolate my c term. Okay, so if I do that here, I have y over v minus a over x equals b over mc, and I want to combine this side into one fraction, giving me yx minus av over vx equals b over mc. Doesn't matter that we have no numbers, okay? Variables are the same thing. And I'm going to cross multiply here. Okay, this is my cross multiplication. I get mc times yx minus av, and it equals bvx, right? Now I notice here I have c and a bunch of crap multiplied by c. So I'm going to divide by all that extra stuff. stuff we got going on. Divide by m times yx minus av on both sides. And I get c is bvx over myx minus mav. Okay, again, doesn't matter that we don't have numbers. All right, now let's talk about division of polynomials. Okay, we're going to divide x cubed minus 2 by x minus 1. And I want us to look at this process. The important thing is you have your placeholders. Okay. And with x, it's the one I'm concerned about. How do I go from x to x cubed and multiply by x squared? So multiply both terms by x squared gives me this. And I repeat the process again and again to get my remainder of negative 1. So I write my x squared plus x plus 1 minus my remainder, it's 1, so minus 1 over x minus 1. Okay, and we can always check our solution by multiplying x minus 1 back in, and it gives us our equation, our problem, x cubed minus 2 over x minus 1. Okay. Now, I know this was a different type of video. It was very fast. They won't normally be like this. Please make sure you go back and pause for any examples you need to see the full work. Okay. And if you have any